right about now. Just getting the stream set up. Okay, great. Hi, welcome everybody. Welcome to this workshop. We're going to be making a simple DeFi app, and we're going to be doing a lot of introductions to new tools here. So if you're new to, if you've been following along so far, a lot of the tools that we've built and we've used, we're going to build on top of, and we're going to do a lot of really cool things. So strap in. Let's do this. Get excited. This will be a definitely like an open seminar type deal. So feel free to ask questions. There's a Q&A feature. I'm monitoring YouTube as well. I'll be bouncing back and forth. I'll try to stop at specific times, but yeah, feel free to jump in. So let's do it. So just to quickly show you what we're going to be building, this is a really simple example of a DeFi application. So you've probably heard of yield farming before. You've probably seen a lot of the different stuff that people have been making, people have been coming out with. A simple DeFi tool that a lot of people can make is basically some type of staking application, right? So you stake your DAI, you stake your Link, you stake your ETH, you stake whatever token that you want, and in return you get basically like a reward for using that platform. So like for example, Your Finance has Wi-Fi, Compound has the comp token, and these different basically thank yous that are also governance tokens. So we're going to be going over a simple example of that. So for example, I have my mock DAI in my application here. I'm going to stake 1,000. We're going to confirm, and this is going to be we're doing this on the Coven testnet. And so once that finishes deploying, we're going to see our staking balance update. And we'll just give it a minute to actually finish deploying. And once it finishes deploying, our staking balance will update, and then we can reward tokens based off of the usage of the platform. So something that we want to keep in mind, and this is where the important piece of Chainlink comes in, is we want to reward them based off of their value, based off of some value. So we're going to be pulling in the Chainlink price feeds. And again, if you haven't been following along, definitely go check out like feeds.chain.link and the documentation for these. They're super powerful, but we're going to be pulling in the Chainlink price feeds. There we go. My staking balance is updated. We're going to be pulling in the Chainlink price feeds to give reward based off the value. So now what we're going to do is we're going to issue tokens, issue the reward token to this platform based off of the value of DAI in USD. So we can even pull that up. We can see what it should be. Let's look up DAI USD. So it's $1.34. So if we calculate this, you guys can see my calculator. Except for we're just multiplying by, we should get 1,034 reward token, because we want to be rewarded in our DAI token in USD. So you can't see it, but I just ran the issue token script. And again, we're on the Coven network here, so we'll just give that a minute to update, and then our reward balance should be updated with the new reward token that we were just given. So, we'll hang tight. This is what we're going to be building, and we're going to be using Truffle, Web3, the Chainlink price feeds, and a couple other tools, Open Zeppelin as well. I'll go into what all those mean in just a minute. So great. So it looks like the price changed actually, but we got our reward, and this is which a reward in what's called in our fake token called DApp token. And this is really powerful because then we can give people rewards based off of the value that they contribute to our staking platform. So that's really fun, and this is pretty simple to do. So so all the code for this actually, so one of our judges and sponsors is Dapp University. So this actually, a lot of the code from this tutorial is going to come from from his video. So DeFi project probably has the code in there too somewhere. I think I have it here actually. Oops. So if you haven't seen the video, definitely go check it out. It's a super thorough explanation of how to actually build this. If you want to check that out as well, we're going to be doing a couple of different things here, including like modifying some of the code. But this is some great starter code, and again, Dapp University is sponsoring. So if you're brand new and you want to get a course, definitely go check them out as well, and apply to opt into their prize. So anyways, before we dive into actually building this, let's talk a little bit about some of the tools out there to build these projects. So two of the most popular ones to get started are Truffle and Buildler, right? And so a lot of the workshops we've been given so far, we've been using Remix. And the reason we've been using Remix is because it's really easy to kind of see how stuff works and get started very quickly. But as some of you have started to notice, that following along here, sometimes it gets a little bit, there's a lot of clicking around. There's a lot of manual work that you have to do. You can't really, writing tests is kind of tricky. So Buildler and Truffle are tools that allow you to write these tests really quickly and get spun up really, really fast. So if you're brand new, I would definitely recommend checking out Buildler, definitely recommend checking out Truffle. These are going to be tools that help you out a lot. We are going to be focusing on Truffle today. Truffle is a framework for testing. If you come to the site, this is the Truffle suite. There's the testing, their testing framework is called Truffle. Ganache, we'll get into that in a second, and Drizzle is a front end, because a lot of what we're doing is we're building these smart contracts for the back end. This is what's powering our applications. However, anybody who uses our stuff needs to be able to use it in an interesting way. And so we need to have front end so that they don't have to go into Remix to to actually use any of your code. So front ends are going to be really, really important, and doing front end development is going to be important too. But we're just going to do some simple stuff because we're going to do some simple front end devs because we don't need to go too in depth for this workshop. So these are some tools that we're going to go over. I did want to point out a couple other tools as well. This is Scaffold ETH by Austin Griffith. He's actually one of our judges for this hackathon. It's a great way to get started on a full stack dApp, and this uses Buildler and ethers.js, which is really cool. And so you can get a front end and a back end deployed very quickly. And by back end, again, I mean smart contracts. So if you want something easy to get a full stack dApp, check this out as well. I also wanted to bring this up. This is a Paul Arberg Solidity template. It's also using Buildler. It's also a really nice template for getting just the back end of your smart contracts done. There's kind of some different methodology. Some people think that your Solidity backend and your front end need to be in separate repos. Some people think it should be the same. It's kind of up to you. You definitely don't want one to have to depend on the other. So this is just a backend. Drizzle is again, this is part of the Truffle suite. This is for doing front end work. And there's also Create ETH app, which is for doing more front end work. So the Solidity template is kind of the back end. Create ETH app is more for the front end. These are all some tools to definitely check out to get started. So with that, I wanted to jump into some Truffle pieces just to kind of introduce you to Truffle before we get into actually building what we're going to be working on today. So I'm going to switch to my terminal real quick. Sorry, 1 second. just realized that I had not cleared out my workspace yet from testing. Okay. Can you guys see that? Okay, cool. So to get started, there's a lot of different ways to get started with your full stack dApp here. So one of the easiest ways is to use a truffle box. And what you're going to do after installing truffle and npm, and you can install truffle with npm install truffle-g. That's going to install it globally. And you'll also need npm. A lot of the blockchain community works with Node.js. There's also some Python pieces like Brownie and stuff, but we're going to be focused on Node.js here. So after you install truffle, you can run truffle unbox smart contract kit /box. And what this is going to do, it's going to download a whole bunch, and it takes a couple minutes. It's going to download a whole bunch of basic folders and files for us to use that will give us kind of a really nice framework for testing and deploying our smart contracts. And again, for the backend, right? And these are tools meant to make, as developers, our life a lot easier. Truffle has a lot of nice pieces and frameworks for doing everything. So this is going to be kind of the standard Chainlink box that making that simple API request. It's going to be all scripted out in these files here. We're going to go over everything that goes in, and yeah, again, it takes a couple minutes. But if you don't want to unbox, you can always just add it to whatever. Add it to whatever you're working on. Let me pull up the Chainlink docs and flip back over to that real quick. So while that's unboxing, you can always just also add it like this. Chainlink, npm install, or you use it with Yarn. You can use the Open Zeppelin starter kit. Actually, that's another really good one. Truffle box. There's a whole lot of different features. Again, we're just going to be focusing on the truffle box for now. But yeah, it takes a couple minutes, it seems. Takes a little bit longer than anticipated. But yeah, once we get in here, we can do a lot of all the deploy, fund our contracts, write scripts so that we can test and iterate really easily. So, all right, we're finished deploying. Let's go back here. Cool. Unbox successful. Sweet. Fun little play on words. Clear. And let's actually, I'm going to open up. Well, let me just flip back. I'm going to open that up in my VS Code now. And now we're going to flip back. All right, cool. So now we're in our VS Code or whatever text editor that you want to use. We have our console here so everybody can see that as well. Awesome. So so here's kind of the basic layout of Truffle, and I'm just going to kind of explain what is in this unboxing for this type of setup. And again, you can use whatever setup that you want. This is just kind of a quick and easy one to get going. So our contracts file is going to be really our main file that we're going to work on. I'll talk about migrations in a second. Is this big enough? Oh, that's massive. If this isn't big enough, somebody just let me know. We're talking about migrations in a second, but my contract.sol is going to be where we're looking to really get started. So this contract defines everything in that make an API call documentation. So you know how we deployed it with Remix, we make an API call. There's a couple other functions in here, but this is all of our, this is all of the code. This is all written in Solidity here. We can see we have our create request to function. where we do, hopefully this is looking familiar to you now, we create this where we send a Chainlink request, right? Instead of hard coding everything here, we just have a whole bunch of parameters being passable so that we can just pass whatever we want here and get any URL that we want, which is really powerful. We have a couple other really helpful commands as well, but this is all of our Solidity code. Now, something else to mention, you'll notice that the imports look very different than that in Remix. That's because with Node.js, we can use this fun @ syntax, whereas Remix, you have to import directly from GitHub. So that is something that will trip some new people up. That's just something to keep in mind. So this @ syntax is for Node.js. The other syntax is for GitHub. And the GitHub won't work here, and the @ syntax won't work in Remix. So these are doing the same thing, though, as like this @ syntax is doing the same thing as a GitHub import. And the GitHub import is doing the same thing as the @ syntax, only these ones we install with, like npm install open zeppelin contracts or whatever, right? When we do our npm install, which all the node modules are actually already here. So there you go. They're already installed with it. So cool. So that's kind of just the layout there. Migrations are going to be basically how it's defined that we're going to deploy our smart contract. So you can think of migrations and deployments as kind of the same thing. If you ever worked with database migrations, it's the exact same thing. We can define in these migrations JavaScript files how we want to deploy our smart contract. So this is kind of a little bit more involved, but basically we're just deploying our Chainlink smart contract. So this basically just defines how to deploy mycontract.sol. We probably don't really need to go over it, but if we want to do more interesting things, if we want to do like another deployment, we just do 3, new migration.js. And then in here, usually I just kind of copy paste. And then in here, we could just do deploy.deploy. If we had a new contract .sol, and then whatever parameters for the new contract. And the reason that you want to do this is because sometimes when you're deploying, sometimes you need to have contracts depend on other contracts, or maybe you need to script up a whole bunch of things to get them connected. That's what this is for. We probably won't get into governance at all, but when it comes to like governance and working with interfaces, this is really good for that too. But so this is, long story short, this is how you, this is what defines how you deploy your contracts. Node modules is node modules. Scripts, these are going to be things that you can run to make your life a lot easier, and they're scripts. So we have a script that's actually going to fund contracts for us. So you know how in Remix we had to like click MetaMask, copy the contract, the address of the contract, send it. We can just run a quick script to fund contracts. We can run a quick script to request data and read data. So this is all really fantastic. And testing is kind of what is the whole purpose of Truffle in the first place. Running tests is what's going to, as you're developing, make sure that your contracts aren't doing anything silly, right? So it's going to be really important as you're building to test, because otherwise you're going to have to kind of manually keep doing stuff. There's a whole lot of kind of like baseline tests in here. You can check it out. We'll go into developing some tests in this demo. We're going to skip over it, like kind of explaining what this one is doing for now, but tests are really good. And then the other important package or file to look at is this one, truffle config. This is what defines all of your truffle features. And yeah, this one's pretty simple, but there you can go to the Truffle documentation to learn more about what's in here. Kind of the important pieces to look at are the compiler version of Solidity is 0.6.6. So this is one of the newer versions, and our networks here. So if we have like a local ganache running, we can connect to Ganache here. We want to connect to a Coven network for this demo. So the first two things that we're going to need, hopefully you're becoming familiar with process.env. This is setting our environment variables, mnemonic and RPC URL. Mnemonic is our wallet mnemonic, and RPC URL is like our Infura URL. So to get these in here, we could do export mnemonic. And this is where you do like apple, banana, hopefully I can spell that, pear, you know, blah, 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 et cetera, whatever your mnemonic is, you can check, you can find that really easily in MetaMask or whatever other wallet you're using. Just look for the docs on how to find the mnemonic. And then same thing, you know, export RPC URL. I already have these exported, so I'm not going to. And this is going to be like infura.io/coven/ you know, whatever. So those are going to be the pieces that you need to get this going. Now let's go into some of the commands. Truffle compile. This is how we are going to compile our contracts. And this is something that you're going to do a lot because you want to make sure that your contracts are even good. If I do some random stuff here, then I run truffle compile, they should not compile. Great. Truffle compile is working. Cool. So now we can play with actually deploying some of these contracts. So we can do truffle migrate. This is going to be the command to actually do everything. And we're going to do truffle migrate network live. So this is the flag that we choose our network on. We're going to use live. And again, that's defined here in our truffle config. We are using a Coven RPC URL. So this should deploy to the Coven network. So if we hit enter, it's going to compile our contracts. It's going to start doing our migrations. And if we wanted to, we can open up Etherscan and grab these transaction hashes, grab the contract address, grab the account, and see everything. So let's, so we're saving migration to chain here. So great, so it looks like we actually deployed these. Let's grab this contract address. Pull up Etherscan Coven. I'll flip to it in a second. I know you guys can't see it. Hopefully you can see it now. But you can see we just deployed this, right? So that's like a fantastic script that we can use to deploy stuff really quickly. Okay, let's flip back. I wish there was a faster way to flip back and forth. So we can also go into what's called the truffle console. And this is like a, oh, whoops, excuse me, truffle console -- network live. And this is like a shell for working with all the truffle pieces. So we can do let contract equals await my contract dot deployed. And we can just type in contract and it'll show us all the information about the contract we just used. We can do contract dot address. We see the address of the contract, which is what it just gave us in case, you know, you run up, you run through all of your, what am I trying to say? You clear out your shell and you can't remember what the address is anymore and you want to check up on it. You can find all that information here in the truffle console. So it's kind of like the truffle's magic to make everything work, which is really nice. Oh, whoops, quit, clear. Great. So now that we have, we've deployed our simple contract here, we can do truffle exec. We can fund the contract, and we're going to fund it with one of our scripts here. We're going to use this fund contract script. So we're going to do truffle exec scripts fund contract.js. And again, we got to use network live. And it's going to fund this contract. And cool, it looks like it funded the contract. We can even, we can double check in the console, but we could also just come here in Etherscan. We'll give it a second to see if it actually gets funded. Our Coven, yeah, I have a lot of fake stuff in here. Don't mind all my fake Coven tokens. But it's actually pulling from this. It's going to send it one link. And great, after refresh, we can see we've actually funded it with one link. I want to actually make it fund way more than that because I know I'm going to be playing around with this a lot. So I'm going to update it to 10 link and I'm going to fund it again just so I can send it 10 link real quick. So now, just to give you the basic rundown of requesting an API, we're going to exec the request data network live. And again, this is just literally it's just going to be calling that request data method in our smart contract. And we see all these parameters in here. And then let's even toggle word wrap. Ugh, that makes it worse. Maybe I should, if I do this, is that hard to see? I just want it to be easy to see for you guys. Maybe let's undo. Oops. Hello. Maybe it formatted it. Oh, that's formatting. Yeah. Okay. Yeah. Anyways, you can see, you know, where this is where kind of the more important stuff. This is kind of just setting the variables up here. We're doing const MC equals await my contract dot deployed, literally exactly what we did in the Truffle console 2 seconds ago. And then we're going to make this transaction by doing my contract dot create request to, which again is one of the functions in our smart contract, create request to. And then we're going to input the parameters specified in the my contract, which is going to be the Oracle address, the job ID, and we use a little Web3 magic to make this string a hex because the job ID needs to be sent in bytes. So the payment, we send the URL, which we're defining here is again kind of this simple API here. And then the path, and then times, and then hopefully you guys have been following along, so you know why we need the path, the times, and the URL. So enter. We're creating the request. Great. It looks like it was successful. And again, remember, we need to wait for the Chainlink node to pick up this request, go get the data, and then split it back on chain. So if we also have this read request, this read contract file, which is much simpler because it's just a view, right? We're just going to call my contract.deployed, mc.data.call. In my contract, we have the price of Ethereum, and this is just called data. So, all right, actually, let's close some of these. We're just going to call data, right? And so call is something that you can use when you have a function that's just like that's just a view, right? So data is technically a function. It's just a view function, right? So that's kind of how you can think about that. And then again, view functions are functions that don't take any gas and don't cost any transactions. So I'm looking at Etherscan right now. It looks like it's just about done. So hopefully our read, read contract. A read contract will actually give us something, or it'll just spit 0. So we probably need to wait another minute or so for the Chainlink node to finish making that request. But this is probably a good stopping point while we wait for that. So I'm going to answer a couple questions here. Size is fine. Thank you. Okay, great. Part of my project is users making several contracts with each other. Think like Upwork freelance jobs. Is it usually better to manage all that state on one deployed Solidity contract, or have users deploy multiple instances of a contract class? What factors should go into making that design decision? That's a really good question. So you're thinking, so the two, so you have two decisions here, right? You have one is where your smart contract contains every single piece of data in it itself, right? Versus having what's called like a factory design pattern, where you have that a smart contract deploy other smart contracts. And it kind of depends on what you want to do for that use case. It almost sounds like the factory smart contract pattern would be better. Now that I'm thinking about like which one is better, or in what situations is one better than the other? I can't think of specific ones, but for that situation in particular, I think the factory contract is better. That's a really good question, though. So now let's try to read it. We should have gotten a response. And we didn't get a response. Maybe we need to just request again, because it is a test net and sometimes things don't work. So we're requesting again. Hopefully this time it actually decides it wants to return data. And if we flip back over to Etherscan, again, we can see 18 seconds ago was that request that we just made. And for this, we just have it set up to be one link, but again, it can be 0.1 link. It can be whatever the node operator charges. But yeah, any other questions so far? This is some pretty standard truffle setup, and then we're going to jump into building that dApp. Have you responded yet? No, you don't want to respond to me, huh? Maybe you want to respond to me now? All right, well, something's going on with my demo here, but can you please give a quick recap in meantime? Yeah, sure. So in the meantime, there's a lot of tools out there to help you get started. We're working with Truffle here. Again, we have our contracts are all going to be on our contracts file. Migrations are going to demonstrate how to deploy your contracts. Node modules is just your node modules. Scripts are going to be, these useful scripts that help you interact with your contracts. For some reason, my read contract doesn't want to work. So sorry about that. I'll have to figure that out later. What is the purpose of migrations.sol? Yeah, this sets up. It's the migrations file. Yeah, this is how like Truffle works with to know when to actually migrate stuff and when to upgrade stuff. So because it doesn't, when you do Truffle migrate, it won't migrate everything. It'll just actually migrate everything. You do Truffle migrate reset. And that's how you kind of force it to upgrade everything. So maybe I just do a Truffle migrate reset. Although I don't think that would work. Read contract. Well, maybe I did something wrong for the read contract, but yeah, I'll have to figure that out later. But anyways, we're going to jump to the dApp. One more question here. Oh, no. Okay. All right. So cool. So yeah, if you have any other questions, feel free to jump on. Sorry that part didn't work, but let's jump into the dApp now. Building this DeFi app. Now that we know what the purpose of Truffle is, why we're using it, and kind of a couple of the tools to actually use it, we're going to be pulling from the starter code, again, from Dapp University's starter code here, which is really, really powerful. Let me flip back over to this. Clear. We're even going to make DRR. We're going to call it DeFi Hackathon Workshop. DeFi Hackathon Workshop. And then we're going to clone a specific branch of this repo. We're going to clone the start code branch. This is how you can clone a repo from the starter branch. Oh, remote branch start rate not found in upstream. Did I do something wrong here? Git clone -b. Oh, starter code. Excuse me. I think that was what's wrong. Okay. CD DeFi tutorial. Great, and we should be on the starter code here. And now we're going to do git check out master branch. Okay, cool. All right, great. So now we're in this master branch, and I'm just going to open this up so my VS Code has everything. Let me just flip real quick. Demos, DeFi Hackathon, DeFi tutorial. Flip back. All right, cool. So now we're in kind of this starter code. And the reason we want to start with this is because it also does some of the front end pieces so we can actually work with it. For us, we're going to focus more on just the back end stuff here. But the front end pieces are really important, obviously, to get anybody to be able to use them. So the pieces that we really care about are going to be in this contracts file right here. And oh, actually, before we even do that, we need to do npm install. We install the packages for it so we can actually work with it. Give that a second here. And I'm also going to show you Ganache, what that is, what it's for, and what it looks like. Yeah, hopefully 2 hours is enough. We probably won't have time to go over everything. Because yeah, this is kind of a jam-packed, like, introduction to truffle, introduction to DeFi, introduction to Ganache. But yeah, what we're going to be doing is we're going to be opening up Ganache. So Ganache is part of the truffle suite. It's a tool that allows you to have a local blockchain. So what we've been working with before is Coven or is a testnet, right? But we want to be able to test locally sometimes because we don't have to go find the faucet for the Coven, the faucet for the faucet. We can just deploy and test locally. So Ganache is going to be something that we can do to play with this. And I'm just going to show you kind of what it looks like. So you can go to the Truffle website, download Ganache. Once you do, here's basically what it's going to be looking like. So it's, you can see, like, here's the different addresses. They each have their own private key, which you can upload into your MetaMask to actually work with it. It'll show you the blocks, the transactions. Let me update my location. Let's remove this project. Let's add a project. Save and restart. And now we can see there shouldn't be any contracts yet because I haven't deployed anything yet, but we can see all the contracts and stuff in here. So this is kind of like a nice UI to work with, like, your own local blockchain. Something that you need to keep in mind is that we're working with Chainlink. Chainlink Chainlink nodes are monitoring the real blockchain. So they're not going, if you start making requests to your local blockchain, it's not going to be able to pick anything up. You can fork the main Ethereum chain into your local ganache, and the truffle deep dive next week is actually hopefully going to go over that, which will be really exciting. But this is for doing local stuff. Anyways, cool. So we have npm installed. Let's go over what we want to do here. So in our contracts, we have these two tokens that we need to define. Now these are ERC20 tokens, and this is this code in here is kind of like the boilerplate for an ERC20. So you might have heard ERC20 a lot in the past. ERC20 just means it's like a framework for building a token. It just means, hey, they have this transfer function, they have this approval function, they have this balance of. It's just a way of a framework saying, hey, here's what it should look like. So in this starter code, there's all these functions that get these two actually started. I am going to do a couple things actually. I want this to be. I want this to be V6. I want to use the latest and greatest. So I'm actually going to update these all to V6. And we need to build these. This is going to be our fake, our mock DAI token, so that we can stake on our platform. This is going to be our DApp token, which we're going to reward them for using. And then again, we have our migrations file. So again, if I hit truffle compile, it might error out. It'll actually definitely error out. And you'll see this. Truffle is currently using SOAK 0.5.16. We can actually fix that pretty quickly, but just by adding version. Right here. So now it'll update so that we're using, oh, we also want to, excuse me. Something that you'll notice too is you'll have to delete, where is it? It's in ABIs. Oh, there's another one using this. Did I not save? I didn't save. Okay, never mind. Save. Okay, now it works. Now we can truffle compile. Great, and they're all compiled successfully. And you'll see this ABIs file gets made. ABIs in Truffle, it's also known as artifacts, and it's the ABIs of our smart contracts. ABIs are the piece that we need to interact with any contract. Whenever you want to interact with another contract from inside your contract, you need its ABI and its address. So this just deploys our ABIs here so we can actually work with them. So when you hit truffle compile, it updates these. If you ever have an issue where it's being confused and it thinks something really weird is happening, you can just delete this file. Oops. Delete this file. Excuse me. Delete. Move to trash, and then you can just recompile, and it'll re-add those to the ABIs file. Cool. Boom. Awesome. So what do we want to do here? So we want our mock DAI. We want our mock DAI to be able to be sent, to be transferred into our platform. And this is kind of the boilerplate code to do this. I'm going to make, I'm going to change something here to show you guys it's even easier than this to get your ERC20s deployed. So this by itself is a way for you to actually you can make your own token right now, and it's super easy because there are all these tokens, Chainlink, BAT, comp, DAI, they're all ERC20s and they fall along this ERC20 standard. So they all have the same functionality. So we probably should have a package that gets them all in for us. So we're going to use this excuse me. We're actually going to, let me just even delete everything. We'll just build it from scratch. We're going to be using the Open Zeppelin package to make our DApp token because it'll make sure we don't mess anything up, right? It's a really powerful package that we can use to for our application here. So we're going to import this Open Zeppelin package, and then we're also going to need to install it here. So do npm install Open Zeppelin contracts. And this way we don't have to define all those functions ourselves. It'll just come natively with this erc20.sol. Something to note, you'll probably see like ERC20 detailed. That was V2 of Open Zeppelin. We're using the latest and greatest here, where they bundled everything together. Now we want to make our contract DApp token is ERC20. Again, this is the inheritance of Solidity here. And we're going to set up the constructor. Public ERC20. Oops, did I do that right? Yep. No, I didn't do that right. What do we want to do? We're going to give the name and the symbol. DApp token. And also the APP. And then we're going to give it the initial supplies with this mint. So we're going to send it. Oh, I see a bunch of questions. You're on Ganache terminal. Oh, whoopsies. Okay. Sorry, we're showing what's talking. Let me switch. Sorry about that, guys. Nope, wrong one. Can you guys see this? Sorry about that. I can go back over it. Okay, yeah, sorry about that. Yeah, let me just undo everything. How much did I miss? How much did I go over? I probably didn't go over too much. Did you guys see me compile and like delete the ABIs, right? You saw that? No, you didn't see that. Okay. Nope. Okay. Sorry about that, guys. Thank you for bringing that up. See if this compiles. So, okay, so you can use truffle compile. Before, if you didn't see this, these were version 5. And if you do truffle compile with different versions, you're going to get this error. I went into my truffle config, switched it to 6. I guess I should look at the chat more, huh? I just switched it to 6, just added this in here, and changed all my my 3 tokens here to V6, right? And now I can do truffle compile, and this is going to compile all my contracts for me. So great. So they're all compiled. And great. So again, this is a like some simpler boilerplate code to get your ERC20 tokens going. And again, an ERC20 token is just literally defining, hey, this is what the functions of an ERC20 should look like. We can go ahead and just make this even easier by using Open Zeppelin's package, because that way we don't have to define any of this. And we can be sure we're not going to mess anything up, right? Because we're going to use Open Zeppelin's package to deploy these. So we import it right here. And if you guys didn't see it, we also need to install it like this. What happens if I install it twice? It's going to be fine, right? Node.js, please. And then while it's installing, we're going to define our contract, DApp token. I could also use Yarn. Yeah, Yarn, please. Contract DApp token is ERC20. And this is, again, is the inheritance. So we're inheriting everything from this ERC20 package, which has all these functionalities, because again, this is also an ERC20 token, this DAI token, which we'll fix this one in a second too. It just doesn't have the name or the symbol, right? So contract DApp token is ERC20. Constructor public ERC20. We're going to call it DEP token, comma D DEP. And this is where you just give the name of it. So we're calling it DEP token, and then we can even see this in Etherscan, and the symbol is going to be DEP. And then we mint the initial supply. So we're gonna mint. So this is how we started out. You can also do like, like UN 256, initial supply or whatever. We're just gonna hard code it for now. And we want to say, hey, we only want 1 million DApp tokens. So we're going to do this for that, which again, this looks like a massive number, but you got to remember everything on Ethereum is in way. There are no decimals here. So this is actually 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can look at it and see that it's in fact a million, right? Just keep that in mind, like just add 18 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. So great. So our initial supply of our DApp token is going to be 1 million tokens. Cool. And then we can do the same thing for DAI, our DAI token here. Literally the exact same code. We just change a couple things. Do DAI token. And then we'll call it, what did I call it on my last one? We'll call it mock DAI token. Give it mDAI for the symbol, mDAI. And we're also going to mint, let's mint a lot more. 1, 2, 3, 4, 5. Actually, no, let's just keep it the same. Why not? So we're going to mint this. So this one will also have 1 million. So there will be 1 million of each one. And these are our contracts to start. So let's truffle compile. Got an issue here. Expected semicolon. Truffle compile. Did the other one also expect a semicolon? Probably. Yep. Whoops. Something else. So far requires different. Oh, sorry. I actually need to make this 0.6 because 0.6.2. I think the import requires 6.2. That's why it needs that. So, okay. So yeah, so we just update this to 6.6, or we could even do 6.2. I'm just going to use 6.6 because I know there's a lot of stable stuff in 6.6. Truffle compile, and great. We are all set to go. Cool. So our DApp token and our DAI tokens work great. And I'm going to briefly look at the questions here. There aren't any questions. Fantastic. So let's deploy this now. Let's figure out how to deploy these. So over here we have our. I got to speed this up. We're going to do deploy contracts.js. Because again, right now we don't have a way to actually deploy these, right? We could do, if we do truffle migrate, I think we're just going to get an error. Oh, actually, I have Ganache running. Never mind. So it's actually just going to run this, and yeah, that's all it ran. So nothing's actually going to happen. Let me actually make this an intelligent thing. Deploy contracts.js. And let's figure out how to deploy these. So we can do const DApp token equals artifacts to facts dot require DApp token. And remember, artifacts is just grabbing from our ABIs. So we have our DApp token in here. This is some truffle magic. We're saying, hey, grab that DApp token. We'll do const DAI token equals artifacts dot require DAI token. Excuse me, DAI token. And we're going to do, now we're going to do the kind of boilerplate module.exports equals async function. just some deployer plate to actually start deploying stuff. Deployer, network accounts. And these are going to be the network to start is actually, we're just going to use our Ganache, just to like start playing around and testing with these. We're going to use Ganache, and let me actually switch over to Ganache real quick to show you what it currently looks like. After I ran that initial migrate script in our local blockchain, we have our migrations file. Oops, contracts. We have a migrations contract deployed, but not DApp or DAI. And the reason we don't have them deployed is because we didn't have it in this deploy script. So this time I'm going to remember to actually go back. Yep. Okay, cool. Grab a couple questions. Extension for second file. Yep. Thank you. .js, not .js apostrophe. Yeah. So now we want to actually deploy our contracts. So we're going to do await deployer.deploy DAI token, because it's an async function here, and then const DAI token equals await DAI token dot deployed. This is how we're actually going to deploy everything, and then we're going to do await deployer dot deploy DApp token. Yep, and then we're going to do const DApp token equals await DApp token dot deployed. Great. So this is how we're actually going to deploy our DAI token and our DApp token here, and then yeah, that's what we're going to do. So this will deploy it to our local blockchain again, because when we're running truffle migrate, saw how before we did truffle migrate network live. That was how we connected to Coven. This doesn't have anything specified, so it's just going to do our default, which is going to be our local blockchain, which I have set up to be Ganache at the moment. So let's go back to deployments. So now, if we do truffle migrate, I will have an error. Cannot access DApp token before initialize. What did I do wrong here? DAI token, deploy to deploy. Something with my case sensitivity. Probably. Oh, yep. Okay, let's deploy DApp token. Did I mess something up here? Capital letter. Where's my, yeah, I figured it was a capital letter, but where is my capital letter? Is that it? No. Is that right? That's probably right, right? Yeah, okay, cool. Thank you. So cool. So now we deployed our DApp token and our DAI token because we defined it in the script. Now, if we flip back over to our local Ganache, we can see that we now have an address for our DApp token and our DAI token. Now, I want to go over tests because this is kind of one of the main things that is why you're using Truffle in the first place, is writing these tests. But I'm just going to kind of speed through it actually, because we're not really going to have a ton of time. But when you're doing these, you can also do like a new file, or excuse me, You want to make a new folder, test folder, and then in here, you can define your tests to make sure things are actually going to be good. We're going to call it new file token farm.test.js. And we're going to do some, I'm just going to dump some boilerplate code in here. Yeah, I'm just going to dump some boilerplate code in here like really fast. Maybe I won't. Actually, yeah, I think I'm just going to skip tests for now. If we have time at the end, we'll go over tests, but they're really good because for deploying, for building all this stuff, you're gonna have to constantly be checking to see, you know, okay, did this do it right? So you really want to do tests while you're building these. You can check out. I'm gonna put the GitHub for this in the with more tests. I'm in the Ganache window again. Thank you. Thank you for that. I'm going to put the GitHub for this for both the DApp University code and the updated Chainlink DeFi product code in the events. And we're probably going to have a blog coming out for this project as well. So stay tuned for that. We're going to skip tests for now, but please don't skip tests. It's really good to write tests. So anyways, so we have our main contracts here, but we need our token farm contract, token farm. Token farm.sol. So this is going to be our, this is going to be where am I in Ganache again? Oh no, I'm back now, right? All right, I'm back. So this is where we're going to find all the functionality of our staking contract. This is going to be our yield farming contract. So again, we're going to start with some boilerplate, pragma solidity right here. And then we're going to import. We want to be able to use these tokens. Actually, let's just open these. Oops. We want to be able to use these tokens. So the way that we can use them in our other smart contracts is by using their interfaces. So we're actually going to import. Open Zeppelin has a great way of working with this IERC20.sol. And what this file defines is the interface of the token. You can't actually import them like this and use them. You have to actually import the interfaces, because if you import the whole token, it'll be confused. It won't know what you're doing. So we import the interface, and I'll show you how to use that in a second. So now we're going to do our contract token farm. String public name equals, let's give it a name, DAC token farm. Then we'll do its address, which will be public. Excuse me, the owner address, which will be us. And now we're going to do IERC20 public DApp token, IERC20 public DAI token. And we'll get into how to use these in a second. So just to kind of get into it, let's do a constructor. And I know that when I deploy this, we're going to need to know the address of our DApp token and the address of our DAI token so we can actually use them. So we're going to pass the interfaces of our DApp token address, IRC20 underscore DAI, DAI token address. This is going to be our public constructor here. And inside, we're going to do DApp token equals IERC20, IERC20. And this is how we actually can work with other ERC20s inside of our smart contracts. We give it the address, and we give the address to the interface, and that's how we can actually work with this. So IERC20 DApp token address. And then DAI token equals IERC20 underscore DAI token address. And then we'll set our owner here. Owner equals message.sender. Okay, cool. Quick truffle compile. Cool, stuff works. So this is kind of the beginning of our application here, and we have like an hour left. So I gotta really rip through this, huh? So what do we want to do here? We want people to be able to function stake tokens, probably a uint amount, right? Like, what else do we want them to do? We want them to be able to stake tokens. Let's think. We probably want them to be able to unstake tokens. To be able to unstake tokens, we want to be able to issue our reward token. So we're going to call that function. We're going to call it issue tokens. Public. And then we're also going to want to function. We want to get the DAI USD price, which will be a view function. It's going to return a UN. So these are probably going to be the functions that we want it to do, right? We want our users to be able to come in, stake token, unstake their tokens, get them back. We want to issue them this reward token, our DApp token, and we want to be able to get the DAI USD price so that when we issue tokens, we can issue them based off of an actual currency here. So these are going to be the functions that we're going to go into. Hopefully I can rip through these quickly. So, and again, when you're doing this, you really want to be doing tests as well. In the interest of time, we're just going to kind of rip through it. So let's have them, how would they stake tokens? So first we would probably want them to stake more than 0. So we're going to have them require amount is greater than 0. Amount cannot be 0. And now we are going to want to transfer from, we want to transfer their DAI token to stake it. So for this one, we're only going to, be focusing around staking DAI tokens, but you can get, any ERC by just getting its address and popping it right here. We're just going to use our mock DAI for the moment. So we're going to use DAI token dot transfer from message.sender address. I'm going to explain what this does in a second. Address this and amount. So because it's an ERC20 token, we know it has this transfer from functionality. And again, you can go to Open Zeppelin and see what all these ERC20s have for their main functionalities. And we're going to say we're going to transfer from the message.sender, which is the person who called this stake tokens method, and we're going to send it to this smart contract, which is our token farm smart contract. We're going to send it to this smart contract and with this amount, right? So that's how we send it in, and that's pretty much how we send it in. Now we need to keep track of how much they've sent in so that we can, issue them reward accordingly. And when they unstake, we know how much they unstake. So to do that, we're actually going to have to do a couple things. So we want to have a list of stakers, and then we want to have a mapping of those stakers' addresses to a uint of their staking balance. We also, we're going to need these two. We need the address to the Boolean. has staked. We're going to need these as well. Set to another Boolean. Public is staking. And remember, a lot of the code for this, a lot of the code is from that DApp University tutorial. So definitely go check out DApp University. Definitely check out everything that they do. We're making just a lot of kind of more, we're chain linking it up a little bit. So definitely be sure to check that out. But we're going to need these. These started out, and now we can go to our staking. We're going to do staking balance of, since we're doing a mapping here, we're going to take the staking balance of the person who just sent it in, and we're going to update it. So we're going to update their staking balance with the amount that they sent in. So we're going to do staking balance. Their staking balance is equal to their staking balance, which will initialize as 0, plus the amount that they just added. And this way we can keep track of it. Now we want to keep track of if they're staking or not. So if they haven't staked, again, this is a mapping, message.sender. We're going to push them onto our stakers array. And the reason that we want both a stakers array and a mapping is because in Solidity, you can't actually loop through a mapping like you can like in Python. Technically, in a mapping, every single address exists. So if you were to loop through a mapping, you would loop through every single address, which would be insane. So every single address that exists in a mapping in Solidity. So we also want to have this array so that when we go to check who is staking, we don't have to loop through every single address in existence, which would be impossible. So we're going to push it on. We're going to update it. Is staking. Sorry, there's some construction going outside. If you guys can hear that. True is staked, or excuse me, has staked. Cool. Now let's do truffle compile. And cool. So it looks like we're compiling. So, and this is why you really want to write tests though, because we're not even sure that this is actually going to work. So you really want to write tests, but I'm just going to kind of rip through. So unstaking, I'm actually just going to copy and paste to do the unstaking because I want to be able to show you guys the Chainlink feature of it. So we're basically just going to do the opposite. I'm literally just copying and pasting from my finished code. That way we can kind of go a little quicker here. But yeah, we get the update, we get the balance of the user from the staking balance. We require that they actually have to have something in here. And then we transfer, we give the balance back to the sender. So something that's interesting is all your tokens are really just like a value on in this DAI token smart contract, right? So everything is actually stored on there. So when we do this transfer function, it's actually getting updated in our DAI token smart contract. So that's something that's pretty interesting. Undo that. Okay, cool. So now we're going to do our issue tokens bit. So this is where we're kind of doing our more interesting piece because we want to issue tokens, but we don't want to issue any token. We don't based on whatever. We want to issue it based on the value of the DAI. So maybe we want to give them for for their total assets in USD. We want to send them, we want to send them a reward token. This way, if we update our application to take other forms of staking like Link, USD, ETH, we can actually send them tokens based off of the total value that they have instead of just how many tokens that they send in here. So we want to be able to issue tokens based off that. So we're going to set this up. So we're going to require message.sender equals owner, comma, caller must be owner. So we're going to say that only the token farm who runs this can actually issue these rewards tokens. So this is what this says. And now we're going to actually issue tokens to our stakers. So we're going to do for uint I equals 0. I is less than stakers.length I plus plus. We're going to get the address recipient equals stakers I. So we're going to get the address of the staker who's staking. Again, we're looping through all of our stakers here. We're going to get the uint balance equals staking balance recipient. And then we're going to say if they actually have a balance, if their balance is greater than 0, then we're going to send them our reward. However, we want to send them the reward based off of the DAI USD price. So we're going to do. I haven't seen those for loops in a while. Yeah, right. So we're going to do dApp token dot transfer recipient, and the amount that we're going to send them is actually going to be, we're going to call a function called get. Actually, let's just call it get. What do we want to call it? Calculated amount. We're going to call it get calculated amount. And this is going to be based off of their balance. So I had this get .usd price. We're going to call it get calculated amount. And then we're going to take a uint 256 balance, and we're going to figure out how much do we actually want to send them? How many tokens do we want to send them? So the way that we're going to do this is we're going to flip back over, and then if I forget to flip back, just let me know. We can go over to the Chainlink docs. We're going to go to our price feeds. So the price feeds, again, is this incredibly powerful decentralized way of getting the price of different assets. So the code is really simple. We even have some Web3 pieces, again, if we want to use it. Since we're doing it in our Solidity contract, we can just look here. And in here, it even has the Node.js syntax for us to use. So what we're going to do is we're going to copy and paste it over. Don't worry, I know that we can't see me pasting it in, but I'm just pasting this at the top, and we can literally grab the rest of this code, and I'm literally just going to grab it, pop it into my method, and I will flip back in a second, and then we're going to edit it. I flip back. Can you guys see me? Can you see me bouncing around? Hopefully you can. So, so this obviously isn't. So I copied the import at the top. We import our aggregator v3 interface. This is going to be the main. This is going to be how we're going to work with our price feeds here. And we're going to figure out how to calculate the amount. And I just kind of dumped a bunch of stuff in here. So this isn't going to be any good. So this is for ETH USD Coven. Let's just clean this up for a second. Hold on. Sorry, I'm like just kind of stripping away some of the pieces some of the pieces that didn't make sense, right? Because I pulled in like a function and a constructor and a whole bunch of other stuff, and I just said no, I don't need any of that. I just want it to be in our calculate price here. So let's even format it a little nicer. Can we actually do top of word wrap? Thank you. Cool. So again, we have our aggregator interface price feed, which pulls this address in. And then once we have our price feed here, we can compile it with, we can get the price with this method from the aggregator interface. Get, latest round data. So this will return all of these values, but we only care about the price, so we're only going to return price. Something you'll notice here too is price is an int. So we actually want to wrap it in a uint. And just to see where we are, let's even just do a truffle compile. Got an issue. Expected this, but got that. Cool. Add the semicolons in. Those are important. Looks like we got another issue. Interface internal. Oh, sorry, this cannot be internal. We can just do public here. Can't be internal. This is a public view, so we need this to be public too. There's another one. Oh, maybe we just expected, but got. Do we just do this? Looks like, yep, we just do that. Cannot find Chainlink contract. I need to install this, npm install Chainlink/contracts, because it can't find our aggregator interface. These are some of the issues that you'll bump into as well. So I'm glad I'm bumping into them to show you guys that you will bump into them. Now let's do a truffle compile. Probably should have done a truffle compile earlier to make sure everything was good. And cool. So we have a couple of warnings. We're saying, hey, this hasn't been used. This hasn't been used, but that's fine. All of our files are compiled successfully. So great. So this still doesn't give us what we want, right? So this just returns the price. And we want to get this calculated amount that's going to depend on how much value that they're putting in our token farm, not just how much tokens they're putting in, how much value they're putting in. So again, I'm going to flip back over to Brave browser here, and remember feeds.chain.link, where you want to get DAI USD. So this here again is the DAI USD price. So we know, like, if they send in 1,000 mock DAI, we're going to reward them with 1,034 DApp token, because we want to reward them for their value, not just for the number of tokens. So we need to get this price feed into our contract. Now, since I know that I'm going to be testing on Coven, what I can do, price feed contracts. Let's look for DAI USD, DAI USD, and this is going to be the mainnet one. Rinkby, is this Coven? Coven, okay. So I know that this is what we want. So let's flip back to, I have like a million tabs open, so it's like a little tricky for me to, is it this one? Ah, what are you sharing? Is it this one? What's this one, right? Okay, cool. So I know I want to put that address here, right? We want to get the address of DAI USD here, and something else that I know because I've done this a lot at this point is I know that the DAI USD price feed has 8 zeros as opposed to 18. So I actually want to get those extra zeros. So I'm going to do times 10 raised to the power of 10. So this is just so that everything's standardized with 18 zeros and I don't have to worry about anything. And you can check it out by looking at the, by pulling this data and like Remix or something. I know it is 8 zeros and I want it to be 18 just so everything is 18 zeros. And you're going to see why in a second, because dividing is a little tricky in Solidity because you can't divide. You can't have decimals. So you got to divide by whole numbers. So so this is just returning the price. Let's even just do price equals, let's call it, actually, no, let's call it calc uint 256 calculated amount, that's my Python syntax coming in, is going to be equal to this, and this is, we want to multiply the balance times this price, and then we want to divide actually by those 18 zeros, right? Because again, we can't get any decimals in here, so we need to multiply those two together and get this massive number, and then just divide by the 18 zeros. And we can do that since they're both denominated with 18 zeros. And then we're just going to return oh, okay, adjust this, please. Calculate amount. I'm going to do a quick truffle compile. And great. Okay, cool. So now we know we can get the, we can issue tokens depending on the value that they've locked in. And this is great because now we have a way of, if we wanted to expand our platform to do more tokens like Link, BAT, ETH, whatever, we can reward them with our, based off of the value of their token, which is really, really powerful here. So that's pretty much it for the token farm. Now what we have to do is we have to deploy it. And I might skip ahead some of the writing up the code because we're running short on time. Where is my migrations? So in here, we're gonna rip through now. Await deployer. Actually, I'm just gonna copy paste because we're running short on time. We're not gonna be able to do any of the front end stuff. Deployer to deploy, again, our token farm. Oh, we need to const token farm equals artifacts dot acquire token farm. And again, we can see that in our ABIs now. We now have the token farm in here, so we can use it. Great. Deployer to deploy token farm. Now we want to do await dap token dot transfer token farm dot address. You'll see why I'm doing this in a second. And we're going to send it everything. So we want our token farm to be the sole benefactor of having all of the dApp tokens in the beginning. So we're going to do dApp token dot transfer send everything to the token farm. And this way, the token farm in the beginning is the only one that's going to be able to send these reward tokens out, which is what we want. So we're going to send them all out. We can also send some mock DAI token.transfer accounts 1. This is going to be your second account, MetaMask. We're also going to send it a whole bunch of DAI tokens. So now I'm going to show you that this isn't quite going to work. Truffle migrate -- reset, because we have a new thing that we want to deploy. Oh, maybe it will work. Just kidding. It will work, but we actually can't. Excuse me. It will work, but we can't actually get the price feed, because this is an address on the real Ethereum chain, and we just deployed it to our local blockchain. So I'm even just going to show you Ganache, and then I promise I'll remember to flip back. Now we have our DApp token here. And again, you can see some really cool stuff. This is on our local blockchain, which is great. We want to now test this on a real, on a real network. We want to test it on Kovan. So again, remember, how do we do that? Well, this networks in our truffle bit is how we define our networks, right? So we want to add in here. We want to add in here our Kovan bit. So I'm going to cheat a little bit, and this is why it's also nice that we did our did I not flip back? I just promised I would flip back. Flipping back. Okay, cool. Thank you. You guys are really on the ball. Appreciate it. So now we're going to flip back, and this is why it's nice. I'm actually going to copy from that truffle unboxing that I did, this live network, which again, it's going to be the same rules apply. We need our mnemonic and our RPC URL. Again, I've already done that. My mnemonic is going to be my test wallet. My RPC URL is going to be our Kovan RPC URL. Now, if we do truffle migrate -- reset, we can also do network live. So this should work. And HD wallet is not defined. I need to add that in here. Sorry, got to add this in here. And then we're also going to npm install this, npm install. Could also use Yarn, but I want to just use one package manager per project, and I've already started with npm. Cool. Now we're going to do truffle migrate reset network live. And cool. So it's going to take a little bit longer because we're actually deploying to the real Kovan chain. And I'm going to flip over to Etherscan just to kind of show you a little bit more. And so that's the DAI token, that's our DApp token farm. And we're going to actually look at the token farm contract that we just made, and we have 25 minutes left, so we're pretty good on time, I think. So token farm contract address right here. Flip over to Etherscan 1 second, and I will actually remember to flip back. So in Etherscan, so this is the transaction hash of getting that token farm up. Let's see if we can. Great. So here's Etherscan of our newly deployed, 38 seconds, newly deployed token farm smart contract on the Kovan network, which is really, really cool. Remember, you do need to have, Kovan ETH to deploy because it takes gas. I have a ton in here. But yeah, and we can even see our token that we created is even listed on Etherscan. It says we have 1 million DApp token. which is really cool. And you can see how easy it is to make these tokens and how simple it is. So now what we want to do is we need to write a script. We need a script so we can actually issue some of these tokens. So let me do a new folder, call it scripts, new file, issue token.js. Okay, cool. And we're gonna kind of do some of the same boilerplate. So we're gonna do const token farm equals artifacts dot require token farm. Thank you. Artifacts dot require token farm, because again, we've deployed it. Oh my gosh. Whew. Keep my promises. Keep my promises. Flipping back. Thank you for being so on the ball. Okay, so starting with some boilerplate, const token farm, artifacts that require token farm, again, because we have it in our ABIs here. And then again, some of the boilerplate module.exports equals async function. Did I spell things right? Function callback. Let token farm equals await token farm dot deployed and then await token farm dot issue tokens. Console.log tokens issued. And then we do our callback. So now we can run truffle exec. And this is how we do truffle scripts. Scripts issue token.js. We're going to do network Coven. And we'll see if it works. Coven. Oh, network live. Sorry. And since nobody's actually staking, FN is not a function. FN in here. Forget to install something. That's right. Oh. Let's try that. All right, cool. So it looks like that's actually working. What did I do wrong before? Ah, export. It should have been exports. Whoops. Okay, my bad. Well, good thing I have my my backup codes here too. So, cool. So it looks like that works. Again, nobody actually is going to get any token because we nobody is staking yet. So, cool. So that's the majority of the functionality. That's the majority of the functionality that we're doing here. You can then write some more scripts like stake token, right? And unstake token. And we don't really have time to rip into building the front end here. Yeah, we don't really have time to rip into the front end here. But what we can do is we can now go back and see our you can actually flip over to the UI that we did make. And this is why having a good front-end engineer is really important with your Solidity products, because you're going to need someone who's strong on the front end to be able to make your application usable by other people. So let's flip back to the front end. Let's flip back to the like completed front end. And again, like all the code, I'll post all the code in the events log so you guys can check it out. I'll post both the DAP University ones and the adjustments that I made with the ERC20 and the value piece. We're getting the latest price from Chainlink as well. I'll also post those bits about like the truffle and box and the truffle smart contracts too. But yeah, again, like definitely check him out. You know, he's got some great resources that make it really easy for you to follow along, you know, no matter where you are in your development journey. So cool. So we're back in this UI here of the DApp token farm, which is connected. Right now it's completely empty. We have our obnoxious amount of MDAI, and then I've been playing with a bunch of this, so I have like a whole bunch of weird stuff here. But we have our MDAI here, and let's stake 1,000, or let's stake let's stake 25 stake. MetaMask is going to pop up, and again, this is all with the front end work. We're going to confirm, we're going to approve. Don't worry about this for now. We would hit confirm, and we can see this on Etherscan. Whenever it finishes populating. Cool. So we sent it to this contract. Excuse me. It's here. And now it should be populated. Great. So we have 25 MDAI. Now, again, we want to issue tokens, and we're going to do that in our little scripts that we just made. So I'm not going to show that. I'm not going to flip back, but yeah, we just do that truffle exec script issue tokens network live script, and we should get the reward balance of DApp token equivalent to the value that we have staked, not the MDAI that we have staked, the value in USD. And you could absolutely get like the value of MDAI. You could have it the reward be ETH in be related to BAT, be related to whatever currency that you want. We're just doing it for USD for simplicity's sake, but you could absolutely do whatever you want to do. So great. So we got 25.75 DApp because the value of this in USD is $25.75. It's if mock DAI was DAI. So that's fantastic. And then we can unstake, which is us just pulling it out, and that transaction's happening. And then we'll see that happen on Etherscan as well. Interact with this, which is our DApp token farm. And right now it has the 25 mock DAI, but since we just unstaked, now it doesn't happen anymore, right? And it got rid of some of its DApp token because it gave it out as a reward. So we can see literally everything in here. We can see the ERC20 transactions that happen with our mock DAI, with our DApp token. We can't really see the contract because we'd have to decompile it. But yeah, so that's pretty much it for the tutorial here. Like I said, I'll post the code for DApp University's starter code, DApp University's end code, as well as the Chainlink parts and the Chainlink adjustments and the open zeppelin, and I'll post that all in the events page so that you guys can all take a look. But yeah, thanks everybody for coming, and happy to take any questions in the meantime. The code that I'll post will have all the UI, the front end pieces, so that if you want to play with that, you absolutely can. Yes, this video will be available later. It'll be posted to YouTube. If you want another really good video resource, again, the Dapp University resource is really good. You know, it was his project that inspired this demo in the first place. So if you want another video, definitely go check them out. This one goes into kind of the open Zeppelin pieces a little bit more. It also goes over truffle with Chainlink much more in depth. But yeah, definitely be sure to check that out too if you want to see the inspiration. I have a question, might not be related, but I would like to ask. If an external adapter starts posting wrong data and the smart contract gets affected by it, how to verify data before going with it? Yeah, unrelated, but a really good question still. So I kind of want to let somebody else answer, because I feel like at this point, I know a couple of you have been following along. You know, what do you think's the answers here? If one external adapter is posting the wrong data, smart contract is going to execute incorrectly. How do we protect ourselves against that? I'm looking at both the YouTube chat and the Q&A here. Anybody know? Feel free to type your answer in that Q&A feature. If one external adapter is returning bad data, if our smart contract is getting bad data from an external adapter, how do we know whether or not to verify it? What do we do? Smart contracts execute whenever data comes in. Decentralization. Yeah, exactly. Decentralization. You never want to have, you know, one external adapter being the source of your smart contract. For developing, that's fine. But you always want to have a decentralized source, right? You never want to have pull from a single external adapter. You want to have a network of external adapters, and that's how you can be assured that your data is good, right? So you're going to pull from a number of sources, from a number of nodes, from a number of oracles, and that's the best way to do it. Again, you know, for the hackathon and for just getting started, using a centralized oracle is usually good enough just to get going. But when you move to production, those are going to be the issues that you are going to run into. How do I make sure my data is good? So you use a decentralized network of external adapters, use a decentralized network of data sources. So we always need trusted sources, like more equal to 50. Yes. So you want to have all your sources be trusted. You don't want to have 51% of your sources be trusted. You really want to have as many trusted sources as possible. And again, the decentrality just protects you against the ones that won't be, or the ones that get bribed. Good question. So you want to, and this is something that's really important when it comes to reputation of oracles and reputations of data providers. If an oracle is responding with poor quality data, you kick them off your network, right? You don't have them anymore, because if they're not going to bring their best to the table, you don't want them to be on your network. So good question. One of the nice pieces again about the price feeds is that, you know, that's kind of that network creating of the network is already made for you for that really common data like pricing data. So that makes it really, really nice and easy just to kind of not even have to worry about building a network or kicking people off your network or seeing who's answering reliably. So that's a really good question though. Thank you for bringing that up. Is it best practice to host your external adapters on the same LAN/VPN as your node? Or can you just host them on the cloud? I guess the latter case, the adapter would need to be served over TLS. You can really do whatever you want. As the same, it's probably better practice to have them on different servers, to host them in different places, because, you know, if one gets hacked and then the other one is still okay. For external adapters in particular, it's usually pretty easy to do the serverless functionality, because then they won't even be hosted on the same place, and they won't even be every time your external adapter gets called, it'll be hosted in a different place because of how the serverless functionality works. I guess in the latter case, the adapter would need to be served over TLS. Yeah, you can host them on the cloud. It's kind of up to you, as long if you're really worried about like best practices and security. and you're going to run a professional node, and you're reaching that or professional node, professional API, professional external adapter, I would really look into some type of security audit, and they'll give you even more information on how to best run it the most efficiently and the most effectively. So definitely a security audit. Any other questions? These are really good questions. All right, if there's no other questions, I'm actually going to jump into the hackathon chat for the next, yeah, I'll be jumping into the hackathon chat for the next probably half an hour. If you guys just want to chat or talk about anything. I think that this is our last, oh no, just kidding. There's an AMA at 5. If you guys want to jump in there. I'll jump in the hackathon chat right after this for about 5 till about 2:30 probably. Then I'll jump back on at 5. There's office hours tomorrow as well at noon. If you want to go even deeper into, you know, whatever you want, if it's just, hey, like, here's my idea. Hey, why isn't this working? Happy to give you a hand wherever you need. But yeah, this was the DeFi tutorial. I hope that you all learned something. Please leave me any feedback as well, or what you'd like to see next, or what you didn't understand, so that you know, you guys can be super successful here. Thank you for keeping me honest, Horatio. Thank you very much, and I will talk to you all soon. All right, thank you.